Hi, it's Tim. Today we are continuing with our build of the Denise Micro ATX Amiga board. So let's get on with it. This is where we got to before. Here's our Denise board. We've got some ESD diodes on the front and we've got ESD diodes on the back, and we've got a bunch of transistors, capacitors and a few resistors. We put resistors on last time, but then we took them off again because I discovered that they were the wrong ones. So now we have a box of parts from DigiKey, loads and loads of stuff, and we've got some replacement resistors, and we are going to continue as we were before with the new parts, and we're going to see how far we get. So we're going to start with a couple of capacitors from the bottom of the board here, which we didn't have before. These are 27.5, and then we're going to go on to the resistors. And what do we know about resistors? Well, resistors are futile. Right, I'm hoping to get close-up shots this time, somewhat better than before, but we shall see how we get on. So, two of these. Double check this, C81 and C82. If you like tinkering with electronics like I do, there's a good chance that at some point you are going to want a printed circuit board being made. And whether it is your own design, for example, or something that somebody else has designed, then our sponsor PCBWay is the ideal place to get it made. So you take the Gerber file, which either you get from your PCB software, or it comes from the website that you download the design from, or from PCBWay's own shared projects page, and you set a number of options, including the number of boards you want to be made and the color that you want. I like various colors. I do different revisions of the same board in different colors. It helps know which is which. And then starting from $5 for 10 boards, off you go. A week later you'll get the boards back. But that's not all. They also do CNC machining, sheet metal work, 3D printing, injection molding. If it's to do with PCBs, they do it. So check them out, www.pcbway.com. Right, I do seem to be missing a load, which I thought I'd bought, but it looks like I hadn't, so we can't fit those. That's a bugger. I don't want to start putting in sockets and things until I finish doing all the surface mount. So that's as much as we can do for now. So what I'm going to do while we're waiting is put that to one side and take a look at this. This is the SIMM memory module, and for that we have got 4 RAM chips. Let's put the thingy on, strappy strap. So these are our 4 chips, and we also have a bunch of 1206 capacitors. So I need to figure out how we're going to fit these chips, because the pins bend underneath the sort of J shape. So we've got 2 on the front, 2 on the back, although that might be 2 on the back, 2 on the front. I don't know which way around it goes. Doesn't matter for the purposes of this. All we need to do is make sure that pin 1 lines up with pin 1. These are going to go on here like that. I think maybe I'm going to turn them around that way. You see, if there was just one side, I could do it with the hot plate. But I think what I want to do is tin these pads, because gold doesn't seem to solder too well, and that will let me solder to it more easily. So that's what I'm going to do. Try it with one first. Let's try it this one. I need to keep checking the camera so that I can see what you can see. That's why the camera has to be on the right of the table, because if it's on the left, I have no way of seeing the picture until literally I'm editing it. So I think basically that goes on there. Now, has that stuck? The answer is yes, it looks like it has. Double check it's the right way around. Yes, it's the right way around. That would be embarrassing. Now we'll do a quick continuity test. Pin 1 there should go to the top of that resistor, so this will just be a very quick check. Yep. Right, I think that worked, so we'll do it again for the other one. And then we'll do it again for the other side. Yep, that also looks soldered. So that's the first side done. Okay, so what comes next are the capacitors. So what I'm going to do is start with the 1 microfarad, 2 of them, courtesy of RS Components. None of your digi-key this time. They may be bigger, but they're no more easy to get out. If you've got any tips for opening these tapes, please feel free to leave them in the comments. Lube it up. Seemed to work. Secret is to come in at a high angle with the tweezers. Okay, that is done, all bar the cleaning up. So I'm trying these little mechanic sponge things. So they're basically, it claims that they're cotton, but they feel sort of spongy. And then what you do is you pick up the sponge see, it cleans it up. So when you're doing it with cotton buds, it does feel like you're leaving bits of detritus all over the place. And these definitely seem to have a more positive picking up action. So now we come to the through-hole parts, and we're going to start with resistors, resistor packs and diodes. These are the lowest bits on the board. You see we've got our massive packs. We're going to start with diodes 1N4148, and there are 4 of these. So you have to be careful with these to get them the right way round. The black line, I don't know if you can see it, the black line goes to the bar and the bar is at this end. There we go. There's 2 10 ohms. So that is all the resistors done. Next item, simply put, sockets. Okay, it says don't socket 9, 10, 11, 12. So we won't do those. Right, I've got that socket out, finally. So I can put this one in. Hurrah. I don't have a 16 that's narrow enough. These are just a little bit too wide to go in that gap. So I'm going to have to make it out of 2/8. like that. It's 42 pins. So again, I'm going to have to make that up. Right, that's all the sockets. We don't have sockets for these 4 because it says in the manual don't put sockets in those 4. So now, massive soldering. And there we are. So just need some cleaning up on the back and then we'll be ready to do the next bit. Transistors and capacitors. I have 3 transistors which are already clipped because I accidentally tried to put them onto my breadbin C64. I'm sure you saw that video. If you didn't, you should. It says in the manual, make sure that these are as close to the board as you can get them. There are some ICs that we need to solder directly to the board, at least according to the instructions, so that's what we will do. Now there's 4 of them, but I only actually have 3, so one will have to wait until it arrives. So this is the 373, which is U11. This is the F244, which is U9. And this is the F04, which is U12. So now it's time to harvest the A500 Plus and put the chips from here into here. 3, 2, 1. So we've just got these 2 chips to do, which need to come out from here and here. So I need to unsolder those and then put them in. Okay, everything is now plugged in. Memory is attached, power supply is attached. All it needs is for us to switch it on. Even the monitor is attached. And here goes the moment of nothing happening. Whoa, there was smoke. So these 74HC245s were found to be in backwards. I've tested them in the T48 and they do seem to be okay. So let's put them back in the right way round. And give it another try. So this is going to be without the memory. If we get anything on the screen, it's going to be a green screen for no memory. Now I'm going to break out the thermal imager, and I used this off camera before, so you can see not very much going on. Let's do our magic zap of the power. Oh, green screen. We've still got a hotspot there, but it's nothing like it was before. And we've still got a hotspot there, but again it's nothing like it was before. 38 degrees. Right, this time I'm going to plug the memory in and let us see what it does this time. Right, the memory is in and we've still got a green screen. Okay, but that is an improvement. Okay, so now we've put the diagram in. That hopefully will give us a diagnostic. Let's focus on the screen so that we can see what goes on. Okay. Right, we get diagram on the screen. I cannot go any further because I haven't got anything plugged in that will generate keyboard inputs. It says chip 512K fast 0. Okay, now that looks fairly straight. We might need to put this in as well. And that is ready to do some more testing. So this is now effectively complete. That way I can put in a keyboard which goes to the PS2 port. It's not a particularly fancy keyboard, but it's a keyboard. And that will allow us to access the functions of the diagram, and we shall be able to run some further tests. I've also reflowed the contacts on this SIMM, so hopefully it is going to be better. I didn't find any shorts, but there may have been something that was not connected. We shall see. Okay, we have diagram. We're going to get the flashing screen again. Right, we're still flashing red and green. That means that we still have RAM problems. Okay, well that's an improvement. We've now got 1 meg of chip RAM. We had 512K before. We still don't have a CPU. That's because it has not passed the memory test. And we don't have any fast RAM because we don't have any fast RAM. So to recap, this is a 2 megabyte SIMM. It's got 1 meg per side. I think it's divided into 16 bits. So byte 1, byte 2, byte 1, byte 2. I think, but I could be wrong. So, memory tests, extended chipmem test. There we go. I don't know what that means. It suggests green is okay and red is not. So if that is 1 byte, and that is, then that would imply that the low order byte is fine and the high order byte is not. We've got dead blocks and we've got bad blocks. I bet it's going to say the same thing for all addresses. There seems to be no variation in that. So I'm going to call that and we'll think of something else to do. So now what I've done is I've plugged in a serial cable to the serial port, and that goes through a USB converter to my Mac. And we are going to record the terminal output of this machine when it boots up and see what it says. Here we go. Now I've got another SIMM from Andy at Hack Build Restore, who has previously built one of these machines. Please check out his channel. I'll put a link to his video in the top corner there. So this came from his Denise board, so we know it works. We're going to plug it in and see what happens. Set the terminal up again. Power to the Amiga. And there we go. So I couldn't read that quickly enough, but I think that had the same memory fault, and we'll see that it's actually gone to a yellow screen, which is a processor exception, I believe. So that doesn't even give us the menu. So having tried 2 RAM sticks, here we are, this one and this one, and getting the same result, I have to conclude, with this one being a known working RAM stick, that in all probability this one actually does work. And the problem is on here. So I spent most of the day figuring out how these RAM sticks work. And I got hold of the schematic and I looked at that, and I got hold of the pinout for the RAM, and I looked at that and I beeped it, and I worked out exactly what is connected to what and kind of how it works. Because although we've got a schematic for the board, we don't have a schematic for the RAM. So don't let the double-sidedness of this fool you. It is in fact a 72 pin SIMM, starting pin 1 there and pin 72 there. Both sides are actually connected in the socket. So if I take that out, that side connects to that side, it's just strapped across. So all the decoding happens on the PCB and on the main board. And just like on a Commodore 64, the access to these chips is controlled by RAS and CAS. There are just more of them. This board is organized as 4 chips of 256K by 16. So it's a 16-bit word. These are 32-bit RAM sticks. Some decoding has to go on here to convert that into 16-bit RAM sticks. 256 by 16, 256 by 16, 256 by 16, 256 by 16. And that is RASed and CASed and address decoded on here by a mixture of Agnes, which generates the RAS and CAS signals, and these 4 soldered in chips, or at least 3 of these soldered in chips, that basically take the address. That one handles the address, and this one between them handle RAS and CAS. This one does RAS and this one does CAS. And so I hooked up some test probes, and you can see the sort of scattered detritus. This is kind of like an OR after the patient has died. These are the 2 RAS lines, these are the 4 CAS lines, and I measured them to see what was going on. RAS gives a signal, and if you've seen the scope output of RAS and CAS on a C64, you'll know exactly what we're looking for. So RAS is fine, it's split into 2, RAS 0 and RAS 1, and then CAS is split into 4. It starts off as 2, so coming out of Agnes we are using CAS on a byte-wide basis. So there are 2 signals, there's CAS L and CAS U, so CAS lower and CAS upper. And then this chip here, which is the 74A HCT139, that is a demultiplexer, and that takes the CAS signal and it combines it with the address 9 from here, and that produces CAS low 0, CAS low 1, CAS upper 0, CAS upper 1. And I measured those on the back of the SIMM chip on these wires here, and I got a good signal on RAS 0 and RAS 1, that's fine, that's those 2. And I got a good signal on CAS low 0, that's the blue one, CAS low 1, which is the green one, CAS upper 1, which is the red one, and nothing on CAS upper 0, which is the white one. And you can see the trace that I got on the scope. Basically, that does nothing, those 3 do something. Now, I believe that the Agnes is working fine, because if we didn't get a CAS upper signal from Agnes, we wouldn't get the red one either. So I'm reasonably confident that's working. In any case, I don't have another one. Those are very expensive chips. Lower seems to be working fine, and RAS seems to be working fine. All these other chips on here which are socketed, I have tried replacements. I've got alternates for all of them, and there is nothing wrong with any of those. So I think, if you disagree with me, please tell me why in the comments, but I think the problem is this 139, because it appears to be not producing one of the CAS lines. Now I can't think of any reason why it shouldn't. I have reflowed it. Yeah. But then this happened. And it was while I was testing this, I may well have accidentally brushed something against something, I don't quite know what, and unfortunately I didn't have the camera running. Maybe you can see it on this chip here. We have blown it up. You can see we've got a nice big mountain in the middle of it. So this is now in fact dead, which gives us a problem. Fortunately, the rest of the machine still seems to work. It still goes through with this and produces our yellow screen, which we've seen previously, but the diagnostic comes out of here and we can read that on the Mac, on the terminal, and it goes through exactly the same as it did before. All the signals seem to be exactly the same, but I think that is the problem. Now, I don't have another one of those. It took about 3 weeks to get that one. So this is going to be as far as we can get in this video, unfortunately. But I think that's the problem. I can certainly get another chip and we can take that out and put a new one in, and hopefully it's going to work. So if you want to see that, please make sure that you're subscribed, and it is free. Give the video a like, it helps with the algorithm. Check out my Patreon if you are that way inclined, and I will see you next time. See ya. Bye.